Welcome to the DESI ASTRO. In this Python tutorial on NumPy, we are going to understand the functioning of the function called np.mgrid, right? So this mgrid function is a NumPy library. So for generating a multi-dimensional mesh grid coordinate or index from a coded vectors, right? So it can be one dimensional, two dimensional, or in dimensional, okay, depending upon your uh, requirement. So basically what it does, it creates grid coordinates over a specific range, okay, and you can evaluate your function on that grid points. So here you can see that the basic syntax of the np.mgrid function is square bracket you can give, and then a start index, a stopping index, and the step. So step can be 1 2 3 4 in between two uh, in two indexes, right? And you can give the multi indexing, okay. So you can create a one dimensional, two dimensional, three dimensional, and n dimensional mesh grid. So let's start it. Okay, so before doing that, I will import library NumPy. So import NumPy as np. So this will take care of our numerical Python and number and arrays, right? Now I will create a one-dimensional mgrid. Okay. So for that, call here x, right? x1d, right? And type here np.mgrid, right? And then give a square bracket. So you can give your start is 1 index, right? You can go up to 10, right? And you can give say 10 step, right? So now print what is this is. So what is the mistake? Okay, so there should be yeah. So here you can see that you have like only one, okay. So you can give a step 1. So you have like 9, right? So this way you can like create your grid, okay. So you can also give 2. So 1 3 5 7 9. You can also give here 0. So 0 2 4 6 8. So this way you can like create your grid, right? In the same way you can like also get your 2d, right? So I will just copy paste this, and here you can create your 2d, right? So just give a comma and go from 10 to 20, and you can give say you can step give as a 1, okay. Then make your 2d, right? So here you can see that you have like a 2d, okay, 2d mesh grid of the coordinates. You can also check the shape if you want, right? So on dot shape, so you can see you have two-dimensional data. It has 5 rows, and I mean like a dimension is like a 5 and 10, okay. So this one contains 5 numbers, this one contains the 10, okay. This way you can do the stuff, right? So this way you can get a three-dimensional. So bus, I mean you have to add the numbers, okay. So I will just copy paste this, and I will get a four-dimensional mgrid. So go for third. So 30 to 45, and then I will go from 100 to 200, and then 20, right? So make here a 4D, right? So run it. So here you can see that you have four-dimensional grid points. First one is of 5 dimension, 10 and 2 and 5. Okay, so this is like the 2, right, 10 and 5. Okay, so you can keep the mesh grid, you can extract it, you can also do it. Okay, this is how you can create your mesh grid, right? So from indexing, you can see the shape is 4, means a 4 dimensional. 4 dimensions there. First one is contain 5 elements, 10 elements, 2 elements and 5 elements. So this will like a mesh grid of the your 4 dimensional index, right? You can also make a 3D for your, I will make here 3D for time being, right? So make 3D here, and so I will just put here 3 from, say I will go from 0 to 10 and 10, then 10 to 20, 10 to 20, 10, and then 20 to 30 and 10, right? Now I'll print. So here you can see that you have 0 to 10, make it 1, not 10, 1, 1, 1. Now it's fine. Okay, so here you have like 3-dimensional grid points. We have like each contains 10 elements, right? So you can also do from here, say x1, x2 and x3, right? So if you print here x1, see what it turns, this grid, and you can see the shape. So it's a 10 into 10 into 10. I mean it's a 3-dimensional data, right? So in a similar way you can check for the your all individual messages, right? And then you can print here x1, x2, x1. So either x1, right? You can print x2, you can print x3, right? So all shapes have the same shape. Okay, 10 rows, 10 column and 10 channels. Okay, so you can do. Now let's introduce complex number. Okay, so like introduce complex steps. Okay, see what happens. So give her y equal to np dot mgrid, right? And you can give here 10 to 20 and give here say 2j, right? See what returns. So you can see it has returned 10 and 20. I mean only 2 numbers. Now give 1. Okay, so it's returns only 1. Okay, so when you give a complex number, no, so okay, so it will like return only 1 number in that. Okay, so give here 10. Okay, so you can see here it is turning 10 numbers, 10 indexes in that range. Okay, you can make it say 9j, so 10 to 20. So this way you can make it, okay, using complex steps. So it gives a specified number of index in for complex step. Okay, so I hope you got the idea that how to visualize this np dot mgrid function and how to create multi-dimensional grid points from the coordinate vectors. So thank you.